Hello everybody, this is Mike Fauché, and today I'm excited to talk about the TBS-h574TX from QNAP. This is an all-new SSD NAS that's aimed at creators, power users, photographers, and videographers. This powerful but small device has 5 SSD bays that are compatible with NVMe M.2 drives via the included adapter and the new E1.S form factor for larger capacity storage. To add even greater flexibility and performance, it has 2 Thunderbolt 4 ports for portability and direct connect, as well as a 2.5 gigabit and a 10 gigabit network interface for high-speed connectivity when you're attached to your home network. If you want to learn more about this device, then definitely watch the rest of this video. And please don't forget to subscribe to see more videos like this, as it really does help support the channel. Full disclosure, before we start, I did reach out to QNAP and they did agree to loan me this unit for the purpose of doing this review. They haven't sponsored or paid for this review in any way, and the results and opinions are my own. They'll be seeing this video for the first time along with you. I did want to give a special thanks to the QNAP team for loaning me the hardware and making this review possible. The TBS-h574TX is aimed as the ultimate device for content creators and power users that are looking for a device that can be both portable when you need it, as well as make a fantastic high-speed network NAS when you're connected to your network. Packaging is really well done, but there's really not a whole lot in the box. You get the device itself and a 120 watt power supply, as well as a 10 gigabit compatible Ethernet cable. The device has a 13th gen Intel Core hybrid processor that has both performance and efficiency cores. And it's available in either a Core i3 with 12 gigs of RAM or a Core i5 with 16 gigs of RAM. Neither of these configurations are upgradable, and for testing I'll be using the i3 version with the 12 gigs of RAM. When it comes to connectivity, this device comes equipped with both a 2.5 and a 10 gigabit network adapter for maximum performance on your local network. In addition, you can get even faster performance by connecting it directly to your PC or Mac using the Thunderbolt 4, giving you up to 20 gigabits of performance. To add to the flexibility, you can use both the network ports and the Thunderbolt ports at the same time and allow 1 or 2 computers to access the NAS directly while still making it available to others on the network. In addition, there's a USB 2 and a USB 3 Gen 2 port which operates at 10 gigabits per second. You also get an HDMI port to connect it directly to a monitor and the power input jack. The top 2 40mm fans are mainly to cool the NVMe drives under extreme loads and stay pretty quiet under normal conditions. The bottom is a vent port for the CPU fan. In the front of the device, you get another Thunderbolt 4 port, a 10 gigabit USB 3.2 Gen 2 port, the copy button, and the power button, as well as the status LEDs. The TBS-574TX comes with 5 swappable drive slots that are pre-configured with the adapters that support M.2 NVMe drives, but it can be configured to support the new E1.S standard form factor that are both longer and wider devices than the current M.2. The E1.S form factor allows for more chip density than the standard M.2, making larger capacity PCI storage drives possible. We'll cover how to attach the device using Thunderbolt port later in the video, as this is also done through QFinder Pro. Other than how you attach to the device, whether you're using the network port or the Thunderbolt port, the setup is exactly the same. For the best data protection and performance, the device comes by default with QNAP's QTS Hero operating system with native support for ZFS for the highest data integrity. But unlike some other ZFS-based storage solutions, this version of ZFS on these devices allows you to expand your storage by adding a single disk at a time if you'd like to your array without the need of creating an additional pool. This is vital for a device like this, as you don't have enough space or drive bays to add pools or entire pools, and preloading 5 SSDs at a time can be really expensive. Now that we have a better overview of the device, let's put some SSDs in, set this up, and put it through some paces. For the initial setup, we'll start with 3 SSDs to form our initial RAID storage pool. To access the storage bays, there's a small lock switch on the side of the device that when you move it to the unlock position, it allows you to push release and pop off the front panel and expose all the 5 drive bays. It's a really quick way of accessing the drive bays. Pulling on the lever, you can pull out the drive sled so that you can load the M.2s on top of it. There's 2 things that I really like about this particular drive tray. The first is the spring-loaded quick-release clip, making installation and replacing drives a real breeze. Obviously toolless, but it's also very simple. The second is there's sufficient clearance above the drive to actually use a thin heatsink on the SSD, or possibly to buy SSDs with heatsinks already installed. You'll have to check the clearance for yourself, but I'll add links to the units that I used for testing as they worked out pretty well. Once you put all the drives back in the trays, you can load the trays back into the device, replace the front cover, slide the switch to the lock position, and you're ready to power on the device. There are a couple different ways to get this set up, but the easiest way is to use their utility called QFinder Pro. Alternatively, if you're like me, you can just get the IP address from your DHCP server and type it directly in your browser to begin the installation. Either way you go, it will take you to the setup screen and you'll have to agree to the terms of use and hit next. The next screen, you have to decide if you want to complete the install with the current version that's installed on the device, or check to see if there's a new version available. I always prefer to use the most current version, so I'll select that option. Once the download of the newest version is completed, it will reboot and restart the setup wizard. When it restarts, the default will be the version that you just downloaded, so make sure you select it and hit next. On the next screen, give your NAS a name, a username for the admin account, and the password for the admin account. Once you've verified the password, hit next to continue. On the next screen, just select your time zone. In most cases, leave the synchronized option checked and hit next. Unless you have to have a static IP, leave the defaults. As a side note, in my opinion, it's usually better to reserve an IP address at your router or DHCP server rather than to assign one on the device. Select Next on the next screen, and you'll get a warning that your Thunderbolt is disconnected, assuming, of course, that it's disconnected and that you're setting this up with the network adapter. You have 2 options here. The first is to connect the device to the Thunderbolt, and the second is just to ignore it and hit Next. It will still work. You can always set up the Thunderbolt later, so if you're not planning to use Thunderbolt, or if you're not ready to use Thunderbolt right now, you can just set it up at a later time. The next screen is for the firmware settings, which you can leave at the default, but I prefer to get all the updates automatically and set the update time of choice. The last screen is a summary of choices that you made, so look it over and hit apply. You'll be warned that this process will clear all the data off the drives, and since this is a new setup, we can just hit initialize and begin the process. If you are reusing drives, then be aware that it will format them and you'll lose all the data on them. It will continue to load and all the services, so I'll just skip ahead, and when it's done, you'll end up with this page where you can go ahead to the NAS management screen or see some of the tutorials on Thunderbolt. You can look at the Thunderbolt tutorials on your own, so for this video, we're just going to go straight into the NAS management screen and log in using the account that we created earlier. After you log in, hit continue on the data and privacy and scroll down to the bottom after you've read it, of course, and hit continue. You'll be taken to the main desktop and click through the several training prompts, and you'll be taken to the storage and snapshots wizard. Because this is ZFS, we're going to go through a few things a little bit more detail here, as it's important to understand some of the differences if you've only used the QTS operating system before and you've never used ZFS. Stepping through the intro wizard gives you a brief overview of the storage pools and snapshots. When we get to the storage pool wizard, it's helpful to understand a few concepts. As with all NAS or storage units, the first thing you need to do is create a storage pool. A storage pool is simply an aggregation of the individual disks, so in this setup, our storage pool will consist of 3 drives. Hit Next, and then we'll select all 3 of the SSDs that appear. Looking below at the RAID type, it defaults to RAID 5 with 3 drives installed, meaning with the equivalent storage of 2 drives and the equivalent of 1 drive of redundancy. So there can be 1 drive failure and not lose any data at all. As you can see, using 3 1TB SSD effectively gives us 1.7 terabytes of usable storage. You have to reduce it by one drive for redundancy, and you have some file system overhead. Your default will be based on how many drives you've installed in the system. If you had 4 drives, I could have picked RAID 6 or RAID 10 as well as RAID 5, but these would severely affect how much storage is usable. I plan on doing a separate video on RAID and ZFS and best practices, so let me know in the comments if you're interested in seeing something like that. For now, let's leave the defaults and move over to the next screen where we have to make some more decisions. We'll go over what these are, and I'll also share with you some of my recommendations. At the top, which is enabled by default, is storage optimization. In my testing, this doesn't do very much on new drives, but it also doesn't hurt, so I would just leave it enabled. This is a one-time process that only takes a few minutes when you first set up the SSD. The next couple of options are a bit trickier. First is the over-provisioning for the drives. This reserves some space in the event that storage locations on the drive or the pool themselves become defective so that the data can be moved to a safe location. On the surface, this is a good idea. However, most high-quality SSDs already come with over-provisioning on the drives themselves, and unless you're planning on writing multiple terabytes per day, 10% is a bit high. If you use high-grade drives, you can either disable this feature for good, or at a minimum lower it to around 2% to maximize your usable storage space. The next section is even trickier if you've never used snapshots. Snapshots are used for capturing the current state of your storage pool or specific folders, so if something were to happen, you can restore your data to that point in time. As they are block-level captures, when you run a snapshot, only the specific blocks of data that have been changed get copied, so typically the size of the snapshots are kept pretty small. This particular setting determines how much of your global storage you'll be reserving for the purposes of snapshots. As this is a global setting, I typically don't like to reserve this much space. In this example, if I kept the defaults of the over-provisioning and the snapshot reservation, I would lose over 500 gigs of my 1.7 terabytes of storage, which in my opinion is too much. Also, as we see later on, you can reserve space for just a specific folder without reserving it for the entire pool. For purposes of this video, I'll leave it at the default, but I would evaluate your needs before reserving this much space. You can also change the setting at any time, so if you want to start small, you can increase it or disable it completely later on. Lastly is the alert level, which you can set to whatever you want. When you're done, click Next and review all your settings, and when you're satisfied, click on Create. You'll be warned about erasing your disks and losing data, as well as the warning that you'll not be able to import this pool if you downgrade versions of QuTS. Click on OK and continue, and your pool will be created and then optimized. When it's done, it should look something like this. Before we continue, I did want to point out one difference between QTS and QuTS. If we look at the QTS, which is used on most of the QNAP NAS units, under the storage and snapshots, the QTS, we have a pool, which is similar to what QuTS does, but under the QTS, you will also see that you have volumes, as you can see here on my NAS. In QuTS, there are no volumes, and you have instead shared folders, which are directly below the pool level, and they really act as a combination of volume and folder. This seems like a small, but it's a very important distinction as it affects how you create folders on QuTS. In QTS, when I created a volume, I could decide whether or not it was thin or thick provision, but in QuTS, I decide this on a folder level as there are no volumes. So with that distinction, let's create a couple of folders to see how this process is done, as well as better understand how provisioning works. To get a better idea, let's take a look at the pool statistics, and as you can see, I have 1.36 terabytes of data and 1.16 terabytes of unallocated space. Let's create our first folder by selecting Create and then selecting the new shared folder. You're prompted with the folder wizard, so go ahead and click Start to continue. Give the folder a name and optional description. You'll most likely have one storage pool on this device, so go ahead and leave the storage pool number 1. So we can illustrate the differences, let's select thick provisioning for this example and leave the Enable Snapshot option checked and set the size of the folder. I'm going to use 300 gig for this example, but remember this can be changed later on. As I mentioned earlier in the video, you can reserve space for snapshots on a folder level, and below is where you enter that number. I'm going to go ahead and put in 50 gig and then hit next to continue. On this next screen, you can most likely leave everything as default. You can change the performance block, which impacts two things: the read and write performance and the size of the snapshots. Remember that snapshots are block copies on anything that's changed, so this will impact how large the block size is. In contrast, a smaller block can slow down performance of larger files. Unless you know exactly what you need, I would leave the default and click Next to continue. Set the user permissions for this folder and click Next, and on the next screen you can select any options that you want. I typically disable Windows previous versions and Recycle Bin, but that's up to you. Click Next to continue. The last screen is a summary, so take a look at it and make sure it's what you want, and click on Finish to create the folder. You'll be prompted that you can configure this folder as a content folder, which we're not going to get into in this video, and click OK to proceed. You'll also get a warning that read acceleration is enabled by default and that you cannot import this version of the pool into earlier versions of QuTS. Click OK to proceed and it'll create your folder. It may take a couple of seconds to create the folder. Because we use thick provisioning, we can see that my usage has gone up and my unallocated space has been reduced because thick provisioning reserves space on your pool whether or not it contains any data. Next, let's create another folder, but this time we'll select thin provisioning. I'm going to set this folder size to 500 gigs, and I want to point out that the guaranteed snapshot space option is grayed out. When we hit Next, we'll get a warning that thin provisioning does not support guaranteed snapshot space. Because thin provisioning does not reserve space when you create a thin provision folder, it can't reserve for snapshots. You can still use snapshots, but be aware that since you're not reserving space, you may have issues with total pool space as it reduces. If you're concerned about snapshots, then I would suggest using thick provisioning instead. But for this example, I'm going to go back, disable snapshots on this folder and click Next. I will still get the warning, but since I've disabled snapshots, I'll just select Yes. The next screen is the same as we saw before, so just click on Next, and the same with the following screen to select user permissions. The next two screens are the same as before with folder properties and the summary screen. Unless you've disabled this prompt, you'll still get the message on configuring this folder as a content source, as well as the prompt about read acceleration. Once you're done, it'll create your folder. However, this time you can see it did it, and it did not change my usable space, nor did it change my unallocated space. This will only change as I put data on the storage folder. Now that everything is set up, we're ready to test some performance. But before we do any benchmarks, let's walk through a quick setup of the Thunderbolt connection to see how this works, and then benchmark both the 10 gig and the Thunderbolt connections to establish what this device is capable of. You will need QFinder Pro installed to utilize Thunderbolt. This will make more sense later, but unlike Thunderbolt drives that are attached directly to your computer, these units set up as a network interface over Thunderbolt, allowing you the speed of Thunderbolt to your device and allows the device to also connect you through the internet via the Thunderbolt connection, assuming it's attached to the 2.5 or 10 gigabit connection, so it'll act as a pass-through. To keep things simple when setting up Thunderbolt, install QFinder Pro if you haven't already done so. Setting up the Thunderbolt is pretty simple and it can be done with or without the device being connected to a network. As you can see, my device is currently attached to my 10 gig network, and to utilize the Thunderbolt port, just plug in a certified Thunderbolt cable from your PC or Mac and plug it into the front or the rear Thunderbolt port of the NAS unit. You'll be prompted to connect, and if you look at the QFinder window, you should now see the device along with the Ethernet Thunderbolt symbol next to it. Even though I'm connected to the Ethernet port, when you plug the device into a Thunderbolt connector, it will create or recreate to an Ethernet over Thunderbolt connection and take priority over your current existing network connection on your computer. So your network connection is routed through the Thunderbolt port so that you can take advantage and have the fastest possible connection to both the device and whatever you're capable of across your network. When using my Mac Air, I did have to disconnect my Wi-Fi at times in order to force my network to connect through the Thunderbolt port, but once it was connected, it remained and it was really stable. Looking at the network and virtual switch settings, we can see that this is connected to the network interface. And we can see that under the Thunderbolt section, that it has created a Thunderbolt network connection there as well. Now that we've seen how easy it is to set up Thunderbolt, let's see what kind of speed we get from both the 10 gigabit and the Thunderbolt connections. For the first test, I ran this device connected to a 10 gigabit network card and ran the Blackmagic Disk utility. This utility is not really a network benchmarking tool, but it's a good indication of actual throughput that goes to the drive. And as you can see, I'm maxing out the 10 gigabit connection. Next, I wanted to see how it would perform on a Windows machine. So using a 10 gigabit connection, again, as you can see, the performance is pretty stellar. This performance is using standard MTU settings with all defaults on the network. And compared to other NAS units I've tested, this device is faster and more consistent transfer performance, allowing the network to run and not be hindered. Now let's take a look at the Thunderbolt performance. For this test, I used my MacBook Air M1 as my test platform. Remember that this device sets up the Thunderbolt port as a network card. So looking at the activity monitor for networking performance, you can see that from the throughput numbers, this device is moving close to 1.5 gigabytes per second, which is incredibly fast for a NAS unit in this price range. This is truly a great device, and for anyone that is in need of fast and flexible storage. After running this device for a while now, I understand why TechRadar Pro selected this as its 2024 Pix Award winner. After having used this as part of my editing workflow on a daily basis, I can honestly say that I'm really impressed with this device and the performance. I've been searching for a unit like this that has stellar performance and is all flash-based for my daily workflow. And it's a bonus that it has multiple ways to connect. I shoot and edit a lot of video and photo content, and I need something that has this kind of performance, and that can attach to my PC or Mac directly, or just leave hanging on my network, knowing that I have quick access to all that data. As for the hardware itself, I'm really impressed with it overall. It's fast, easy to expand, and with the ability to add a disk or replace all the disks one by one for larger ones, makes it really flexible, especially for a ZFS-based system. Despite having 2 system fans and 1 CPU fan to keep components cool, it stays relatively quiet during most normal operations. I did hear them spin up a couple of times when I was copying huge amounts of data, but most of the time they remain relatively quiet. This behavior is not unexpected, as NVMe drives generate a lot of heat, even if they're outfitted with heat sinks. As for the performance, it exceeded my expectation and was incredibly fast on both network and Thunderbolt. When using Thunderbolt, it was the fastest NAS I've tested to date, rivaling some standalone drives. And connected to the 10 gigabit port, it rivaled the fastest performance I've seen on file transfers. If you're a photographer, videographer, power user, or content creator of any kind, you should really look at this device. Despite being a NAS, it's portable, flexible, and fast. Please let me know in the comments if there are any specific tests or features that you want to see on this device, and if there's enough interest, I'll do a follow-up video on it. Anyway, that's about it for today's video, and again, I want to thank the team at QNAP for allowing me to test this product. Thanks for watching, and I'll see you on the next video.